Hello viewers, welcome to my channel. I'm Hasham. So far 14 problems I have completed on transportation. In this video 15th problem, and the next will be the last video on transportation problems. So if you want the perfect command on this topic, watch the complete video. And the problems are dependent on the theory. Starting 3 videos I have uploaded on theory of transportation problems. So watch all the videos from beginning till end. Don't skip in between and don't join in between. So before starting the 15th problem, I expect my viewers to have a printout of the problems, which is given in the link under my description. Always keep the problems ready. Now 15th problem I am reading out. A manufacturing company has 3 plants X, Y, Z, which supplies to the distributors, the origin plants and destination distributors located A, B, C, D, E. The 3 plants and 5 destinations. Monthly plant capacity are 80, 50, 90 units respectively. So if you add up 80, 50, 90, you are getting 220 units. Monthly requirement of distributors are 40, 40, 50, 40, 80. If you add up the monthly requirement, it is coming to 250. 40 plus 40 plus 50 plus 40 plus 80, 250. The requirement is 250, but the supply is only 220. It is unbalanced. Supply is less. So we make a dummy plant. Already 3 plants are there, X, Y, Z. One more dummy plant we will make to make the problem balanced. Unit transportation costs are given in rupees from plant and to the distributors. Plant XYZ, distributors ABCD, and unit cost matrix is given. Now first of all, the total supply from the plants are 80, 50, 90, 220 units. Whereas total requirement at the distributors are 40, 40, 50, 40, 80, 250 units. So 220 supply, 250 requirement. Requirement is more, supply is less. So to make it balanced, we make a dummy plant with the requirement of 30. 250 minus 220, 30 units. So dummy plant supply will be 30 units and unit cost will be 0. Right? Finding IBFS by them. As usual, I have taken plant X, Y, Z and dummy. Right? Distributors are A, B, C, D, E. For dummy plant, the unit cost will be taken zeros, whereas the supply will be 30. Now if you add up 80 plus 50 plus 90 plus 30, you will get 250. It is balanced problem, no? Remaining costs given. Then row penalties, column penalties for finding out IBFS. Now, penalty is the difference between the smallest cost and the next smallest cost. So in the first row, the smallest cost is 3. Next smallest is 5. 5 minus 3, 2. Here the smallest cost is 4. Next smallest cost 6. 6 minus 4, 2. Smallest is 3. Next smallest 4. So 4 minus 3, 1. Now we'll come to the column. Minimum is 0. Next minimum is 4. So 4 minus 0 is 4. Here the minimum is 0. Next minimum is 4. So again 4. Here minimum is 0. Next minimum 6. So 6 is the difference. Here minimum is 0. Next minimum is 6. So again 6. Here minimum is 0. Next minimum is 3. So here we will take 3. The first penalty completed, row penalty as well as column penalty. What is the highest penalty? 2, 2, 1, 3, 6, 6, 4, 6. The highest is 6. But it is occurring twice. Whenever there is a tie, we compare the cost. If we select the 6, the cost is 0. If we select the 6, the cost is 0. Again, cost is also time. Then we compare the allocations. Wherever we can give more allocations, that cell we will select. Here if we select this 6, how much allocations? 30 allocations we can make. Because column 50, here row 30. If we select this 6, again 30, that means allocations are also time. Penalty tie, cost tie, allocations are also tying, then arbitrarily we can select any one of the 6. Suppose I am selecting the first 6, then the minimum is 0. So what is the row total? 30, column total 50. So 30 I can allocate here. This will become 0. 30 minus 30 0. 50 minus 30 remains 20. So which has become 0? The row has become 0. The row will be blocked. Here I am blocking the row. Right? Row is blocked. Now second penalty. Again minimum is 3, next minimum 5. So 2 is the penalty. Minimum is 4, next minimum 6. 6 minus 4, 2. Minimum is 3, next minimum 4. So 1. Here dash, exhausted, so dash. Column wise, minimum 4, next minimum 5. So 5 minus 4, 1 is the penalty. Minimum 4, next minimum 7. 7 minus 4, 3. Here minimum is 6, next minimum 6. So 6 minus 6, 0. Minimum 6, next minimum 6. 6 minus 6, 0. Here 3. Minimum is 3, next minimum also 3. So 3 minus 3, 0. That's all. What is the highest penalty? 2, 2, 1, 0, 3. So here it is 3. What is the lowest cost in this cell? 4 is the lowest cost. So we allocate in this cell 4. Row total 90, column total 40. So we can allocate 40 in this cell. This will become 0. 90 minus 40 will remain 50. The column is blocked. So here column is blocked. Now I am coming to the third penalty. Minimum is 3, next minimum 5. 5 minus 3, 2. Minimum is 4, next minimum 6. So 6 minus 4 is 2. Minimum is 3, next minimum 6. So 6 minus 3 is 3. This is dash. Column. Minimum 4, next minimum 5. 5 minus 4, 1. Here dash. This minimum 6. 6 minus 6, 0. Here 6 minus 6, 0. Here 3 minus 3, 0. So what is the highest penalty? 6. Round off this 6. Round off the 6. And what is the minimum cost here? 3. 3 is the minimum cost. So how much allocations? Row total 50, column total 80. So I can allocate 50 here. This will remain 0. This will be 30. So row is blocked. This row is exhausted. Right? The next penalty. Next penalty 5, 3 to 5, 2. Here 4 to 6 is 2. Here exhausted. Here exhausted. Now 5, 4, 1. Here it is exhausted. Here 6, 7, 1. Here 6, 6, 0. Here 3 to 6 is 3. Now what is the highest penalty? Here it is 3. So what is the lowest cost here? 3. So column total 30, row total 80. So I will allocate 30 here. 30 minus 30 is 0. 80 minus 30, 50. So column is blocked. That's all. The next penalty. 5 to 6, 1. 4 to 6, 2. Here exhausted, exhausted. Now 5 to 4, 1. Here it is exhausted. Here 6 to 7, 1. 6, 6, 0. Here exhausted. So what is the highest penalty here? 2 is the highest penalty. Round off this 2. What is the minimum cost in this row? 4. So row total 50, column total 40. So I am allocating 40 here. 40 minus 40 is 0. 50 minus 40 is 10. So here column is blocked. Column is blocked. One more penalty we require because 2 unoccupied cells are the last penalty. 6 minus 6, 0. Here 7 minus 6, 1. Here dash, dash. Column wise. Dash, dash. Here 6 to 7, 1. 6, 6, 0. Here dash. So here, the minimum cost, the maximum penalty is 1. Here 1 and here 1. So if we select this 1, what is the minimum cost here? 6 is the minimum cost. 6 is the minimum cost. If we select this one, minimum cost is 6. Again, there is a tie in cost. If we select this one, this 6. If we select this one, this 6. Tie in cost. Now we see the allocations. If we select this one, how much allocations we can give? Column total 20, row total 50. So 20 allocations we can make if we select this 6. If we select this one, so how much allocations? Row total 10, column total 40. Only 10 allocations we can give. Our rule is we select that cell where we can give more allocations. So 20 allocations. Don't select this one. Now select this one. Then here 20 allocations we can give. So 20 minus 20 is 0. Here 50 minus 20, 30. That's all. Now if any cell, if any row or column will have only one unoccupied cell, we'll take the balancing figure. Here you can see, that's how this 0 has become now 50. So this will be blocked. This has become 0. So column is blocked. Now here in the first row, only one unoccupied cell is there. The row total is 30. So we will take 30 here. So 30 minus 30 is 0. Here 40 minus 30 is 10. Now in the whole table, only one unoccupied cell is there. The row total is 10, column total is 10. So I am taking 10 here. 10 minus 10, 0. 10 minus 10, 0. That's all. Now you can see all the cells are either occupied or blocked. That means no empty cell is there. And the total supply and demand all have become zeros. All supply has become 0, all requirement, demand also becomes 0. That means correctly we have made the IBFS. The next step, find out the number of allocations. 1, 2, 3, 4, 5, 6, 7, 8. So totally 8 allocations are there. Number of allocations 8. And m plus n minus 1. Number of rows plus number of columns minus 1. Number of rows 1, 2, 3, 4. M is equal to 4. And n is equal to 1, 2, 3, 4, 5. N is equal to 5. So 4 plus 5 minus 1 is 8. So what do you observe? The number of allocations are equal to m plus n minus 1. So the IBFS is non-degenerate. So we can proceed to find out the optimum solution. The same table again I am repeating. X, Y, Z, then dummy, demand. Then distributor A, B, C, D, E. Same cost I have taken. Demand. One extra row and column U, I and Vj. So UI, U1, U2, U3, U4. And Vj, V1, V2, V3, V4, V5. We are applying UV method. Now we take the allocations. The first allocations are 20, 30, 30. Here 20, 30 and 30. Right? Next one 40. Here 40. This is 10. Here it is 10. Right? Next to 40. Here 40. Then last one 50. So here it is 50. Next to 30. The same allocations what we got in IBFS, I have copied the allocations here. Now check whether it is correct or not. 40, the column total 40. Here column total 40. 20 plus 30, 50. 30 plus 10, 40. 30 plus 50, 80. Row wise, 30 plus 30 plus 20, 80. 40 plus 10, 50. 40 plus 50, 90, 30. That means correctly we got to the allocations. Now any one of the U value we have to take 0, either U1 or U2 or U3 or U4. Because we have 3 allocations in the first row, so what I am taking is U1 is equal to 0. I am taking U1 is equal to 0. The other values of Ui and Vj will be calculated by using this equation. Cij is equal to Ui plus Vj, as usual, every problem we are doing. So without applying this formula, directly we can get these values. What is the Cij here? 6. So here you take 6. Here 6. Here it is 3. So directly we got 3 values. Now other values. Take this cell. What is the location of this cell? Second row, 4th column. So C24 is equal to U2 plus V4. That is equal to C24, second row, 4th column, it is 6. 6 is equal to U2 plus V4. How much we got? V4 is 6. Then take this 6 to LHS. So 6 minus 6, 0. So U2 is equal to 0. We got the value U2 is equal to 0. Now take this cell to find out V1 value. What is the location? 2, 1. So C21 is equal to U2 plus V1. How much is C21 here? 4. Then U2 we got 0 is equal to V1. So plus. So 4 is equal to 0 plus V1, right? In other words, V1 is equal to 4. V1 is equal to 4, right? U2 0. V1 is how much? V1 is 4. Next, we will take another cell, this cell. Because already we are having V3, we can find out U4. So what is the location? 4 and 3. So C43, 4th row and 3rd column, 4, 3. C43 is equal to U4 plus V3. How much is C43? It is 0. 0 is equal to U4 plus V3, how much? V3 is 6. So if we take 6 to LHS, so it will become minus 6. So 0 minus 6 will become minus 6. So U4 will become minus 6. U4 minus 6. Right? Now we take up this cell. This cell, because U3 we don't have now. We'll make use this cell to find out U3. What is the location? 3rd row, 5th column, 3, 5. So C35 is equal to U3 plus V5. C35 is 3. Is equal to U3 we don't have. Plus V5. V5 is 3. So what? Bring the 3 to LHS. So plus 3 will become minus 3. 3 minus 3, 0. So U3 is equal to 0. U3 is equal to 0. Right? Then lastly we need this value. What is the location of this cell? 3, 2. C32. C32 is equal to U3 plus V2. So C32 is how much? 4. Is equal to U3 is 0 plus V2. So we can say V2 is equal to 4. V2 is equal to 4. We got all the values of UI and Vj. Now opportunity cost. The opportunity cost of unoccupied cells can be calculated by using the following equation. Delta Ij is equal to Cij minus Ui plus Vj. So whether you apply that in the formula or directly orally, I'll explain. Cij, what is the Cij here? 5. What is Ui value? 0. What is Vj value? 4. So 0 plus 4 is 4. So 5 minus 4, 1. Opportunity cost 1. Similarly here, 8 is the Cij. From Cij deduct Ui plus Vj. What is Ui here? 0. Vj is 4. So 0 plus 4 is 4. So 8 minus 4 is 4. Right? Now this. Cij is 7. Then 4 plus 0 is 4. 7 minus 4, 3. Here it is. 6 plus 0 is 6. 7 minus 6, 1. Here 6. 3 plus 0 is 3. 6 minus 3 is 3. Here 4 plus 0, 4. 8 minus 4 is 4. Here 6 plus 0 is 6. 6 minus 6, 0. Here it is. 6 plus 0, 6. 6 plus 0, 6. So 6 minus 6, 0. Here it is. 4 minus 6 is minus 2. So 0 minus minus 2 will become plus 2. Here 4 minus 6 is minus 2. 0 minus minus 2 will become plus 2. Here 6 minus 6 is 0. So 0 minus 0 is 0. Here 3 minus 6 is minus 3. 0 minus minus 3 is plus 3. That's all. All the opportunity costs are positive. All opportunity costs are positive. So we reached the optimum allocations. We reached the optimum solution. Now what are the allocations and the total minimum cost? X to C. X to C. 20 units, 6 rupees. X to D. X to D. 30 units, 6 rupees. Then X to E. X to E, 30 units, 3 rupees. Then Y to A. Y to A, 40 units, 4 rupees. Then Y to D. Y to D is 10 units, 6 rupees. Then Z to B. Z to B, 40 units, 4 rupees. Then next Z to E. Z to E, 50 units, 3 rupees. Lastly, dummy to C. Dummy to C, 30 units, 0 rupees. That's all. Now simply multiply 20 into 6, 120. 30 into 6, 180. 30 into 3, 90. 40 into 4, 160. 10 into 6, 60. 40 into 4, 160. 50 into 3, 150. Then 0. That's all. So we have multiplied the units with cost per unit. Now we add up 120 plus 180 plus 90 plus 160 plus 60 plus 160 plus 150, that comes to 920. The minimum total transportation cost is 920 from these allocations. If you change the allocations, definitely the total cost will be more than 920. So 920 is the minimum transportation cost which we can get by these allocations. That's all. This is the end of problem number 15. Only one problem is left, 16th problem. That we'll do it inshallah in the next video. If you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed. And by the super thanks which is given below my video, inshallah we'll continue the next problem in the next video.